Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Everybody, welcome to Wednesday Night Math Night. I'm so excited to be back with you guys. Priya did an amazing job covering me for 2 weeks. With the new job that I have, I just have a lot of events that I have to do and a lot of extra stuff that I have to do. So she covered me for 2 weeks so that I could do that. But I am so happy to be back with you guys. In the 2 weeks that I was out, I did receive a few pictures, a few questions with people asking, like, can you include this in next week? I'm studying this problem. I don't understand it. I love doing that kind of stuff because it really helps me nail down specific areas that you are struggling with. So if you have any questions throughout the week, please don't hesitate to send them to me on Facebook. I'm more than happy to include problems like the ones that you send me so that you truly understand how to solve those problems. So find me on Facebook, Amy Sink, and send me any problems that you want to see me solve in the future. That's helpful for you and helpful for me. I apologize for the way I sound today. I have a really bad sinus infection. So, just battling a little sinus infection, that's all. So I apologize if I start coughing or if I sound sick. Let's get started with an introduction and then we'll jump right into the first math problem. So before we get started, I always like to start with an introduction. So tell me where you're from, what test are you prepping for, and what question should I ask today? Where are you from? What test are you prepping for? And what's your favorite fruit? It's kind of a random one, but what's your favorite fruit? My favorite fruit is any kind of berry. Strawberries, blueberries, blackberries, raspberries. My favorite berry is probably a raspberry or a blackberry, but I like all berries. So what's your favorite fruit? Please go over Praxis 7813 student errors. Absolutely, I will include that kind of stuff in the next week or 2 weeks. I would love to go over student errors. How can you send me questions? Good question. You can email me. I will leave my email in the comments. So you can email me questions that you might have. Hold, please. I'm going to type my email in here for you. At hotmail.com. Okay, there's my email if you have questions that you want to ask me. Bananas, melons, mangoes, pineapples. Ooh, all such good fruits. My son loves melon. He is obsessed with melon. He is almost one. He turns one next week. I can't believe it. He turns one in, oh my goodness, he turns one in 5 days. That's crazy. But he loves melon. All right, let's go ahead and get started with our first problem. We could sit here and chat all night. We could sit here and chat all day about fruits and babies and kids, but we are here to do math. So, hello, you are from Las Vegas. You're prepping for the Praxis, and you like mangoes, grapes, and kiwis. Welcome, TJ. Rhode Island. I love seeing all these new faces in here today. Hey, Arlene. Hey, Joseph. Good to see you. Hey, Bernadette. Lots of new faces. Love it. All right, first problem. Let's get started because otherwise I could sit here and talk to you all day long. Okay. A quadratic equation is given below. How many and what kind of roots does the quadratic have? Okay, so this is totally for my middle school and my high school people. Elementary people, don't on me right now. I have a few problems for my elementary people, but this one is geared toward my middle school and high school people. So, quadratic, gotta know these definitions. Quadratic is a equation or a function that crosses the x-axis a potential of 2 times. So, this is just going to be a little like side lesson. So if I have a graph here, and here, and here, and I were to graph 3 different quadratics, I could have a quadratic that looks like this. I could have a quadratic that looks like this. I could have a quadratic that looks like this. How many times does this quadratic cross the x-axis? 0 times. This equation does not cross the x-axis ever. And it never will because these lines are going infinitely up. So they're not going to just randomly drop back down. Hold that thought. How many times does this quadratic cross the x-axis? Twice. 1, 2. Okay? How many times does this quadratic cross the x-axis? Once. It comes down, bounces, and goes back up. Now, if I want to figure out how many and what kind of roots this quadratic has, I'm going to use what's called the discriminant. If you don't know what this discriminant is, you need to if you're taking a middle school or a high school test. The discriminant is the inside part of the quadratic equation. You don't know what the quadratic equation is? You definitely need to. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, what is a, what is b, what is c? A, b, c. The a is always tied to the variable that is squared. The b is always tied to the next variable, and the c is always your constant in a quadratic. So if the quadratic was written like this, which is not standard form, so you likely won't see it like that, but you could, that does not mean that this is A, this is B, and this is C. You have to put it in standard form to then do A, B, and C. So this is technically still A, this is technically still B, and this is technically still C. Now, what is the discriminant? The discriminant is the inside part of the square root. Why is that important? I'm going to explain to you why that piece is important here in a minute. So if I plug in these values into my discriminant, I have b squared minus 4ac. What is b? A is 3. B is -8. C is 17. I will often write that information out here to the side just so that I don't have to keep going back and forth to my problem to figure it out. So, -8 squared minus 4 times A times C. -8 squared is positive 64 because -8 times -8 is positive 64. And 17 times 3 times 4 is 204. So minus 204. I don't even have to solve that. Why? Because I know I'm going to get a negative number. Does it matter what kind of negative number I get? It does not matter what kind of negative number I get. Why? Here's the big why. The big, like, okay. If I take the square root of a negative number, because remember, all we did right here was the inside of the quadratic formula. And what's the purpose of the quadratic formula? To tell us what the x-intercepts are. Because when we have a quadratic equation, I can solve for the zeros or the x-intercepts by factoring, by using the quadratic formula, by completing the square. I have a whole menu of options. So this is just one way to find the zeros or find the x-intercepts. So if I just do this part and that part is negative, what does that mean? I can't take the square root of a negative number because nothing times itself equals a negative number. So if I get a negative number, a negative discriminant, that means I have two imaginary roots. Because they're imaginary, because I can't take the square root of a negative number. All right, what if I have a 0 discriminant? If I have a 0 discriminant, like if I solve b squared minus 4ac and I get the answer 0, that means that I have one real rational root. How do I know that? Well, it's real because it's not imaginary. I can take the square root of 0. But what is the value of negative b plus the square root of 0? Negative b. What is the value of negative b minus the square root of 0? Still negative b, because the square root of 0 is 0. So no matter what is out there in the negative b, no matter what I'm adding to that, I'm adding 0 or subtracting 0, which just means it's one answer. So I'm going to have negative b plus 0 divided by 2a and negative b minus 0 divided by 2a, which is just going to give me the same thing, negative b divided by 2a. So that's going to give me 1. It's going to be real, and it's going to be rational because it's set up in a fraction form. But if I have a positive discriminant, I have two possible options. If it's a perfect square, I'm going to have two real rational roots. So if I have a perfect square, then I'm going to have two real rational roots. If it is not a perfect square, I'm going to have two real irrational roots because irrational roots. I keep hitting that little arrow. So if it's a perfect square versus not a perfect square. If it's a perfect square, like 16, 25, 49, 64, then I'm going to have negative b plus 8 and negative b minus 8 divided by 2a. But if I get the answer 17 for my discriminant, I'm going to have negative b plus the square root of 17 and negative b minus the square root of 17. The square root of 17 is a really, really, really long decimal that is irrational. It doesn't make sense in our brain. It is an irrational root. When I think of irrational, I think of someone who is like arguing and they're being irrational. So that's an irrational number right there. It doesn't make sense. So this is why the discriminant is super duper important, so that you don't have to graph it. You don't have to figure it out. You just have to use that one piece. So all that said, because we had a negative number for this discriminant, what's our answer going to be? 2 imaginary roots. Can I do a problem about finding the mean from a table that deals with years and age? I'm going to take a picture of that so I don't forget. I will do one next week. If you have an example, can you shoot it to me via Messenger on Facebook, please, just so that I know what you're looking for? Can you have my email? I will give my email out at the end of tonight. All right. Let's go ahead and keep going. X minus 6. This is directly, both of these were directly from requests that people wanted. X minus 6 is a factor of 2x cubed plus 4x squared minus 82x minus 84. The remaining quadratic has how many roots? This is absolutely a 2-step problem because we have to find what the remaining quadratic is, and then we have to figure out the roots that are in that remaining quadratic. So, how do I find what the remaining quadratic is? This is where a lot of us middle school and high school people get stuck because I need a drink of water. This is where a lot of us get stuck because we forget what basic math is. If x minus 6 is a factor, then that means it's a root of this problem. Yes, Bernadette. If I could give you a high five through this screen, I would. Yes, Joseph, both of you got it. So if I have to figure out what the remaining quadratic is, I'm going to do long division or synthetic division. Either one is fine. So I'm going to use synthetic division myself. So I'm going to put 6 here. The number we put in that little box is like opposite of what this number is. And then I'm going to take the coefficients and lay them out. 2, 4, negative 82, negative 84. So from there, I'm going to use my synthetic division to divide. So I'm going to pull the 2 down. If you are not familiar with the process of how to do this division, I highly encourage you to just Google synthetic division videos. Khan Academy is great for that. You can find videos on how to do this. So I'm going to do 6 times 2 is 12. 12 plus 4 is 16. 6 times 16 is 96. 96 plus negative 82 is 14. 6 times 14 is 84. 84 plus negative 84 is 0. So that means that this right here is going to be my remaining quadratic. 2x squared plus 16x plus 14, and that's going to equal our remaining quadratic function. Now, what am I going to do from there? From there, I'm going to use that discriminant, that little piece under the square root in our quadratic formula. Remember, our quadratic formula from the last slide is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. But the only part that's super critical for us to being able to find the roots is this part right here. So that said, I'm just going to have I'm going to change colors. A, B, C. So I'm going to have b squared. I'm going to change colors again. B squared minus 4 times a times c. 16 squared minus 4 times a times c. 16 times 16 is 256 minus 112, which equals 144. What does that mean? That means right there that I have the square root of 12, or the square root of 144, which equals 12 and negative 12, because 144 is right here. And because I have 144, what do I know? I know they are not complex, which means they're not imaginary. I know it's not irrational because I can take the square root of 144. And now I'm down to 2 negative integral roots, or both positive and negative roots. So what does that mean? That means that we have 2x squared plus 16x plus 14, which is factorable, but because of that, because these are both positive, that means that when I do my factoring, I'm going to have a plus and a plus, which means when I set it equal to 0 and I solve, I'm going to get x equals a negative number and x equals a negative number, which is why A is my answer, because I'm not going to have a positive and a negative. Because both of these are positive, I know that when I were to factor them, they would both be positive. So that's why A is the answer. Will I be doing any case 6 problems? You joined just at the right time, because the next couple of problems are K to 6 problems, and they are specifically fraction problems. Are these on the GK exam? So I would say this is not. However, I would say that finding the discriminant and the quadratic like this is absolutely fair game for the GK, because in the blueprint it says being able, it tells you that you have to be able to like solve problems including quadratics, and that includes this. Have I seen a problem this complex on the GK like study guides? No, but it doesn't mean it's not fair game because it is in the blueprint. What does the integral root mean? So the integral root just means that they are integers, if that makes sense. So this says it's both positive and negative, and we were able to eliminate that. And if you didn't know what integral meant, it would actually be okay, because we were able to very quickly eliminate these, and then we were able to eliminate this in looking at the signs. But integral roots, I believe, means integer roots. I'm actually going to Google that just to make sure we are integral roots, just to make sure that I'm like not giving you. Yeah, roots that are integers that are not irrational or imaginary are integral. Okay, I was correct in my thinking. You're welcome. I just wanted to make sure before I like continued on in that explanation. All right, K6. Now, this problem, it would be fair game on any assessment. GK, Praxis, Core, 4 through 8, 7 through 10, because it really does cover quite a bit of content. So let's go ahead and get started. The following circle graph shows the results of 160 students. How many students chose grapes as their favorite fruit? So let's zoom in. What does this graph mean? This graph means that 40% of students chose strawberries. 25% of students chose apples. 10% of students chose bananas. 11.25% of the students chose grapes. And 13.75% of the students chose blueberries. That does not mean that 40 students chose strawberries, 25 students chose apples, 10 students chose bananas, and so on. Because in fact, if we added all of those numbers up really quickly, 40 plus 25 plus 10 plus 11.25 plus 13.75, when we add all of those up, what is that going to equal? I'm going to add it in my calculator, even though I haven't actually, I know what it is, but I haven't actually done the math. So I'm just going to cross-check myself and make sure I was right. It equals 100. Why does it equal 100? It equals 100 because that's the amount of percentage in one whole, right? Like, I'm not going to have more than a whole in a pie graph or in a circle graph. So that said, I already know, I automatically know that does not equate to the number of students. This is how many students took the survey. This is the percentage of those students that answered each question. So, how many students chose grapes? 11.25%. Now, there's a lot of different ways we can do this. Bernadette, absolutely. Is over of equals percent over 100. Yes. So if we translate this into words, how many students chose grapes? Well, grapes is 11.25%. So I want to know what number of 160 is 11.25%. Or I could multiply 160 times 11.25%. Now, if I multiply 160 times 11.25%, that means that I'm going to multiply it by the decimal version of this. So if I have 11.25%, that means that it's going to equal 0.1125 in decimal form. Elementary people, you have to know how to translate percents into decimals and decimals into percents. GK, you have to know that as well. Arlene, you are absolutely welcome. I'm really glad that that helped. So how do I change a percent into a decimal? Well, I'm going to move that decimal 2 places to the left or vice versa, 2 places to the right. So I'm going to hop this decimal 2 places to the left. So 160 times 0.1125. When I do that, I get 18. So 18 is my answer. However, if that's something that when you looked at this problem, you were like, I really have no idea how to do that. Here's how you can kind of like, I don't know, reason with it. If I look at this graph and I think about what is 10% of 160, 10% of any number is just shifting the decimal 1 place over. So 10% of 160 is 16. All I did was take that decimal and move it 1 place over. That's something that you really should become very familiar with. So if I know 10% is 16 and I'm looking for 11.25%, I know that my answer is going to be real close to that 16. I also can look at this and say 40. Well, 40 out of 160, drop those zeros, that's going to be 1/4. And a fourth out of 100 is a quarter, right? Like 4 quarters makes 100. So it's certainly not going to be 40 because that would be 25% of my population. So becoming familiar with being able to manipulate fractions and decimals in our brain like this to be able to determine if our answer is reasonable or not, or being able to say, I really don't remember how to do this, but I have enough understanding of fractions and decimals to be able to play with these numbers in my head is going to be really critical for you as you move forward. Let's look at the exact same graph, but with a different question. Oh, no. Okay, same information, different graph. The following table shows the results of 160 students. What percentage of students chose strawberries as their favorite fruit? What percentage of students chose strawberries as their favorite fruit? So if this is 160 students, if I add all of these up, and I don't need to add all of them up, but sometimes I like to just to make sure, that equals 160. How do I find the percentage of students who chose strawberries as their favorite fruit? Well, I know that I'm looking right here, right? How do I figure out what percentage that is? Well, I know that percents, decimals, and fractions are all in the same family. So if I can figure out the fraction of students who chose strawberries, I can absolutely figure out the percentage. Well, what fraction of students chose strawberries as their favorite fruit? Well, remember, a fraction is just a part over a whole. Like if I say I have a half of a cake, that means that I have one piece out of 2, right? So fraction is just a part of a whole. What is the whole in this situation? 160, because that is how many students took the survey. What is the part that I'm looking for in this specific situation? 64. Because the part that I'm looking for are the students who chose strawberries. Now I can use my calculator if I have one. If I don't have one, that is okay. I'm going to divide them both by 2. I'm going to divide them both by 2 again. I can divide it by 2 again. I can divide it by 2 again. And now I have a fraction that I can easily throw into a decimal. 4/10 is the same thing as literally 4/10 or 0.4, right? If I didn't know that, I could throw this into a division problem. 4 divided by 10. Add a decimal 0, add a decimal, 10 goes into 40 4 times. Could I do that same thing with this? I could have done 64 divided by 160, add a decimal, and I could have solved it that way. If you have a calculator, it makes the world real easy. because you could literally just punch in your calculator 64 divided by 160 and you get 0.4. Now, that still doesn't answer our percentage question. However, I could multiply that times 100% to get my percentage, or just hop that decimal 2 places back to the right, because on this problem, we talked about how to convert a percent to a decimal, which is hopping it 2 places to the left. Now I'm going to hop it 2 places to the right, which gives me 40%. Milagros. Absolutely. You could absolutely do that if you have a calculator and you're willing to, or you can do it by hand. Hope. Excellent job coming up with that answer before I did. Amazing. I love when you guys solve it ahead of me and you get it. That means that what we're doing together is working and the studying that you're putting in is working. All right, let's keep going. Problem number 5. Oh no. Problem number 4B, really. Because I wanted to show you again that we can ask this multiple questions about the same set of data. So here we are. Again, we have the same set of data as we did on this problem and this problem, but lots of different questions can be asked from it. So disconnected. I know I'm reconnecting before I keep going. But I wanted you to be able to see that we can ask multiple questions from the same set of data. All right, while we're waiting for my screen to reconnect, if you're just joining us, please let me know if there's anything that you want to see me solve in the future. I love using problems or creating problems from topics that you guys want to see because it really helps you study. So if you have any topics or specific questions that you would like to see me go over, please let me know in the comments or find me on Facebook or email me. All right, here we go. The following table, same table that we've been working with, shows the results of 160 students. What fraction of students chose apples as their favorite fruit? So now we're not looking for a decimal. We're not looking for a percentage. We're looking for a fraction. So again, like I said on the previous slide, fraction equals part over whole. So what is my whole? My whole is 160. What is my part? My part is apples, which is 40. Now, you're going to look at me and say, Amy, I don't understand because 40 over 160 is not an answer choice. You're absolutely right. It's not. However, we have to go ahead and simplify that fraction. So what we have to do is take that fraction and simplify it. I know I can divide them both by 10. If you're not familiar with your factors, you need to be. Divide them both by 10. How do I know I can divide them both by 10? Because they both end in a 0. So 40 divided by 10 is 4. 160 divided by 10 is 16. I know these are both divisible by 4. So I get 1 over 4. All right. Let's keep going. We're chugging right along. Ooh, this is a fun one. This is another elementary one, and then I think we're going back into like my middle school and high school world. All right. Find the least common denominator of fractions that have the denominators 14 and 8. So least common denominator means I'm looking for the smallest possible answer. There are an infinite number of common denominators. There's all sorts of common denominators that we can come up with, but I'm looking for the smallest one. So I have a fraction that has a denominator of 14, and I have a fraction that has a denominator of 8. And I want to find the smallest possible common denominator. When I look at these answer choices, 14. Is 14 a common denominator? It is not. And I'm going to use my answer choices to help me for this kind of problem. I'm not going to sit here and fumble with trying to figure out what the least common denominator is. I'm going to use my answer choices. 14 is not a common denominator because 8 times 1 is 8 and 8 times 2 is 16. So 14 we skip right over. 22 is not a common denominator because 8 can't go into 22. 22 is not divisible by 8. So not an answer choice either. 56. Now, I know that 8 is a factor of 56. 8 times 7 is 56. However, I'm not so confident about the number 14. So I'm going to list my factors of 14. 14, 28, 42, 56. There it is. I just found my least common denominator. Now, what is 14 times 8? 14 times 8 is 112. Is 112 a common denominator? It is. This is a common denominator. But so is 56. So in that case, which one is the least common? 56. Now, we are often taught if you can't find a common denominator, like let's pretend I said, add these two fractions together. Add 3/14 plus 7/8. And you're sitting here and you're sitting here and you're sitting here and you can't think of a common denominator. Well, we are often taught if you can't find a common denominator, multiply them together because that is a common denominator. So multiply this by 8 over 8. Multiply this by 14 over 14. How come I can do that? Because this is a value of 1 and this is a value of 1. And anything times 1 is itself. So I'm not changing the value. Really, all I'm doing is making the pieces smaller. So this becomes 24 over 112. And this becomes 14 times 7, 98 over 112. And when I add those together, I get 122 over 112. That is not most simplified. Now I have to divide them by 2. So I get 61 and 56. And that would be my most simplified answer. If I used 56 as my common denominator, I would likely not have to go through this step. But it's not wrong. It's just wrong if they ask us for the least common denominator and we say it's 112. It's a common denominator, but it's not the smallest one. Okay? I'm glad that makes sense because I know that some of you made some errors there. I'm glad it makes sense. All right. I am absolutely loving all of the conversation we're having tonight. The amount of comments I'm seeing tonight really means that you guys are paying attention, learning, asking questions, participating. If I had prizes, I would do prizes. Like, I love communicating with you guys, and I just love it. All right, let's keep going. There are two lines graphed on a coordinate plane. Line A is represented by the equation 3x minus 4y equals 15. Line B passes through the point 2, -3. What is the equation of line B if it is parallel to line A? Lots of information here. So we have two lines on a coordinate plane. I'm going to draw my coordinate plane, and I want you to imagine. Now, I'm not saying this is where line A is, so don't get this in your head. But if line A is here, and I have a line parallel to it, what does that mean for these lines? Parallel lines have what? Have the same slope. Perpendicular lines have, good Terry, negative reciprocal slopes. So here's what I want you to think about. If it says, what is the equation of the line? What information do you need to be able to find the equation of the line? No matter what, you need a slope. And then you also need a point or a y-intercept. Because my equations of lines are y minus y1 equals m times x minus x1, or it's y equals mx plus b, where m is your slope, b is your y-intercept, and x1, y1 is a point. However, in this case, they gave us a point, and we need to find the slope. They did not give us a y-intercept. But when I look at my answer choices, they are all in slope-intercept form. Does that mean I need my intercept to be able to solve this problem? No, because I have a point. So I can throw it into point-slope form and then just move some things around to get it into slope-intercept form. So let's go ahead and get started. First thing I need to do is find my slope. So I need to find the slope of this line. How am I going to do that? Put it in y equals mx plus b form. So I'm going to subtract 3x from both sides. And I have negative 4y equals negative 3x plus 15. Now I'm going to divide everything by negative 4 to get y by itself. So I have positive 3 over 4, x, minus 15 over 4. Some of you are going to look at that and freak out because you see a fraction here. That's okay. Fractions are not scary. Here is the slope of line A. What is the slope of line B? The same. Parallel lines have the same slope. And we're looking for parallel lines. So I know my slope has to be 3/4, which means C and D are automatically out. Because C and D have slopes of 4 over 3, not 3 over 4. Now I'm going to take all the information I know, slope and point, and throw it into point slope form. So I'm going to do y minus y1 equals m times x minus x1. A negative times a negative is a positive. I'm going to distribute this 3/4 all the way through. Now, elementary people, hear me out. Elementary people, hear me out. If you checked out because you said, I don't need to know this, I'm going to wait for the next problem. This is where you can pay attention because you need to know how to multiply whole numbers and fractions. So let's go ahead and finish solving this problem with everybody in the room paying attention. So I'm going to distribute the 3/4 and the x. I have y plus 3 equals 3/4 x. But now I have to multiply the 3/4 times the negative 2. How do I multiply fractions and whole numbers? I'm going to turn that whole number into a fraction. So I'm going to turn it into negative 2 over 1. And when we multiply fractions, do we have to have common denominators? No, we don't. So I just multiply straight across, negative 6 over 4. So then this becomes minus 6 over 4. Subtract 3 from both sides. But now, because I'm subtracting 3, I need to get that 3 into a common denominator. So in order to do that, I need to figure out how many fourths are in 3 wholes. I'm going to say that again. I need to figure out how many fourths are in 3 wholes. That would be 12 over 4. So this is going to equal y equals 3/4 x minus 12. Negative 6 minus 12 is negative 18 over 4, which equals, and this was a typo, which equals divided by 2, negative 9/2. So my final answer is y equals 3/4 x minus 9 over 2. I'm going to go ahead and fix that because that was a total typo on my part. Minus 9 over 2. And that's our answer. All right, we have time for maybe one more problem. So I am going to skip because we've been doing a lot with lines. I'm going to skip to some basic geometry. I just kind of want to end with some basic geometry. So, which statement about a triangular prism and a rectangular pyramid is true? Only the pyramid has triangular faces. The rectangular pyramid has an equal number of faces as the triangular prism. Only the prism has a triangular base. Only the rectangular pyramid has rectangular faces. This is one of those problems where we get bogged down in the words and the language. Let's do a really quick review on the difference between a prism and a pyramid. Prisms, pyramids. A prism has 2 identical bases with rectangles surrounding the bases. A pyramid has 1 base with triangles connecting that base. The way a prism and a pyramid are named is with the shape that's out front. So a triangular prism is going to have 2 triangle bases. A rectangular pyramid is going to have 1 rectangular base. The name, the shape out front of the prism or the pyramid identification tells you what kind of base it has. So a triangular prism is going to have 2 triangles, and then it's going to have 3 rectangles, 1 rectangle for each side of the triangle. So how many faces does that prism have? It's going to have your 2 triangles, 1, 2, and then 3 rectangles. So it's going to have 5 faces. A rectangular pyramid is going to have a rectangle base and then triangles extending up. So that means it's going to have 1 on the bottom and then how many triangles? The same number of triangles is how many sides the rectangle has. 1, 2, 3, 4. So it's going to have 5 faces. 1 rectangle and 4 triangles. If I folded those all up, it would create a prism. Y'all are cracking me up. I love that your brains just went, that makes me so incredibly happy that like you guys are mind blown. Like it makes me so excited when I explain something and it makes sense. All right, keep going. So only the pyramid has triangular faces. Well, we know pyramids have triangle faces, but that's not true because the triangular prism is going to have triangular faces. The rectangular pyramid has an equal number of faces as the triangular prism. Well, we just figured that to be true. 5 and 5. Only the prism has a triangular base. So the prism, that should have said, and another typo, that should have said only the pyramid, because that would actually be another true statement, and this only has one true statement. Only the prism has a triangular base. That is correct, because the pyramid has a rectangular base, because it's a rectangular pyramid. So this should say only the pyramid has a triangular base, because that's not true, right? And then only the rectangular pyramid has rectangular faces. Well, that's not true, because the rectangular pyramid has a rectangle, but so does the prism. So therefore, B is the only correct answer. All righty. I am going to get ready to close us out for tonight. I am going to turn it back over to Dr. A. He's going to give you guys a special code. But reach out to me. Let me know if you guys have any questions. If you have social media, I would prefer that you message me the questions that you might have. If you don't have social media, my email address that I use for Learning Liaisons is this right here. So if you have any questions that you want me to go over, or questions that you're struggling with, let me know. I'm more than happy to add them into the upcoming weeks of Wednesday Night Math Night. Otherwise, I'm going to turn it over to Dr. A. You guys have been awesome. I will see you all next week. And I hope that you guys have a great weekend.
All right, so wasn't that an amazing session? Now I know, depending on what exam you have to take, you're like, man,
It looks like we're having technical difficulties connecting back with Dr. A. So I'm just going to close this out, because I can't seem to get it to connect back to him. So I hope you all have a great week, and let me know if you have any questions, and I will see you guys next week. Bye.